So far in class we've been graphing lines by using the x and y-intercepts, and for this lesson we're going to talk about graphing lines based on slope-intercept form. And slope-intercept form is probably the most useful form of a line. I use it a lot with my students in AP Statistics. The form of the line is y equals mx plus b, and I know some of you are familiar with this form because I've heard some of you mention it in class, and we talked about it briefly last week. Notice the y is by itself, and then the number that's in front of x, this m here, is our slope. And some of you might be wondering why m for slope. It's conjectured at one point, instead of the word slope, the word modulus was used since modulus meant change. So m for modulus. But here we still have m representing slope. And then this number here is our y-intercept. And you might be wondering why b for y-intercept. And once again, at one point, it's conjectured that the slope was called a, and so then the next natural letter to use would have been b. So let's take a look at some examples. We're going to identify the slope and y-intercept for each line. Remember, y has to be by itself for us to identify the slope and the y-intercept. And in this first example, y is by itself, so our slope is 2, and our y-intercept is -1. And remember, this is really the point 0, -1. If we were to graph this, the y-intercept is the point that's on the y-axis. And then here we have once again y by itself, so our slope is 1/2, and our y-intercept is the point 0, 6. Here it's easy to see that our slope is 4, but you might be wondering what's up with the y-intercept. There's nothing added or subtracted, and that's correct. It's understood that there's nothing here, or 0 being added or subtracted, so our y-intercept is 0, which means this graph is actually going to go through the point 0, 0, or the origin. Here you might think we can identify the slope and y-intercept easily, but notice y is not by itself, so we're going to have to solve for y in terms of x. We'll get y by itself by subtracting 3x from both sides. And once I've done that, my equation will be in slope-intercept form, and it will be very easy to identify the slope. The slope is -3, and the y-intercept is 8. On this last example, notice y is by itself, but you might be wondering what happened to the x, and that's because this is a horizontal line. So the slope of a horizontal line we know is 0. But usually if we have 0 times anything, it's just 0, and to write 0 plus 5, we just write 5. So we don't actually have it written this way when we have a horizontal line, because basically just like up here we didn't write the 0, down here we're not going to write the 0 as well. But the slope is 0 for this horizontal line, and the y-intercept is 5. Let's take a look at some examples where we're going to be doing some graphing. Graphing this line using the slope and y-intercept. I can see that this is in slope-intercept form. The y-intercept is -3. And the slope is 3/1. And remember, slope is change in y over change in x. So I'm going to go in the +3 units in the y direction and +1 unit in the x direction. So up 3 and right 1 to get another point. Up 3 and right 1 to get another point. And so here is my line, y equals 3x minus 3. And remember, a line goes on forever and ever, so we should actually put little arrows on here. All the points that are on this line, all the ordered pairs, xy ordered pairs, when you substitute them into our equation, make this equation a true statement. So there's an infinite number of ordered pairs that make this equation true. Let's take a look at one more example. Here we're going to graph this line using the slope and y-intercept, but notice it's not in slope-intercept form. We need to actually solve for y. We need to get y by itself. So to get y by itself, I'm going to begin by subtracting 2x from both sides. And you might say, okay, well, y is by itself. Well, not quite. There's a -5 in front of the y, so we need to get rid of that -5 that's being multiplied by the y. And we're going to do that by dividing everything by -5. And make sure you don't just divide the x part here by -5, but also divide the 10 by -5. And so our equation of our line in slope-intercept form is y equals positive 2/5, because we have a negative divided by a negative, that's a positive. Positive 2/5 x minus 2. So our y-intercept is negative 2, and our slope is 2/5. So we're going to move 2 in the positive y direction and 5 in the positive x direction. So up 2 and right 5. And notice I've actually plotted the x and y-intercepts here. So it'd be very easy for us to take a look at our original equation and see if we have the right x and y-intercept. So let's take a look at the original equation. If x were to be 0, so let me just scratch this out for a second. If x were to be 0, y would have to be negative 2 to make this true, which we have as our y-intercept. But what if we pretend that y is 0? So I'll scratch that out. 2 times 5 would give us 10, so our y-intercept is 5. So that's correct. We'll be taking a look at more examples of slope-intercept form and graphing lines in slope-intercept form in class, but don't forget to do the survey at tinyurl.